Good evening and welcome to Kepler's. We've been serving the community since 1955 as an independent bookstore, and we're proud to host tonight's event with John Allen Paulos. C-SPAN is filming this event. Please be aware that you may be filmed. Tomorrow night at 7:30, food writer Jeanette Ferrari will be here to discuss her latest book, MFK Fisher and Me, a memoir of food and friendship. All are welcome and refreshments will be served. John Allen Paulos is here with us tonight to talk about his latest book, Once Upon a Number, The Hidden Mathematical Logic of Stories. The best-selling author of A Mathematician Reads the Newspaper, Paulos now brings us a witty account of the connections between literature and mathematics, explaining how stories can be used to correct the excessive abstraction of statistics, and statistics can be used to correct deceptive storytelling details. John Allen Paulos is a presidential scholar at Temple University and has authored numerous papers and several books. Please welcome John Allen Paulos.
Thank you. It's a pleasure to be here. Thanks for coming. Let me begin by reading a little snippet. At his faint chuckle, she turned and faced her once beloved uncle. Unceremoniously, she ripped the papers from the pocket of his Hawaiian shirt as he warily stepped backwards towards the hotel room door. And then, with unmitigated disgust at his blubber as well as his duplicity, she hissed. 22.8% of all bankruptcies filed between July 95 and June 97 were attributed to bad legal advice, up 9.2% over the last biennial period. Anyway, as this snippet is intended to suggest, but may not, the stories we tell in our everyday lives often coexist uncomfortably with statistics of supposed relevance, even when the two don't outright contradict each other. The book, Once Upon a Number, is about the gap between stories and statistics, or to vary the alliteration between narratives and numbers, or more generally between a kind of personal agent-centered view of the world and an impersonal scientific view. You've probably all seen these posters of New York with New York in the foreground and the rest of the country receding into the background. Our own psychological worlds are somewhat similar. We're in the foreground and everyone else is in our background, is in the background of our psychological worlds, and annoyingly we're in their backgrounds. And how to reconcile these egocentric self-conceptions or urbanocentric posters with a more objective view is, again, part of what I'm trying to get at in the book. I've always felt torn between stories and statistics and their very different logics. In Enumeracy, I tried to, among other things, I looked at the potential of narratives to impart mathematical notions. In A Mathematician Reads the Newspaper, I looked at mathematical aspects of stories in the news. In this book, I focus more explicitly on the differing logics. I've been struck, for example, one thing that got me to think about the topic, by how frequently people I know talk about being wronged or aggrieved by other people, and how infrequently they talk about wronging or aggrieving others themselves. And we can't all be so Lake Wobegon above average. And it's got me to thinking about the difference between personal views of chance and objective probability, between informal conversation and logic, between meaning and the technical definitions of information. And the book that resulted is a sort of mathematician's take on C.P. Snow's two cultures idea, the literary and the scientific. And it's my attempt to bridge the gap or at least illuminate it. The stress, though, throughout the book is on examples and puzzles and vignettes and paradoxes of various sorts. One example is Murphy's Law. Whatever can go wrong will go wrong. And lots of instances of it which are based on probability to one degree or another. For example, if you have 10 pairs of socks, you take them to the laundromat, and the laundromat chews up 6 individual socks. The worst possible outcome is these 6 socks come from 6 different pairs, and you've got only 4 complete pairs of socks. The best possible outcome is that the 6 socks come from 3 pairs, and you're still left with 7 complete pairs. And it's not too hard to show that the worst possible outcome, only 4 pairs of socks, is more than 100 times as likely than as the best possible outcome. So it makes no sense in this case to talk about bad luck or malevolent agents. It's just what happened. Socks happen. And in general, in more serious cases too, and people who tend to see conspiracies wherever they look, I think beliefs of this sort are to some extent motivated by desire for self-aggrandizement. I mean, if the world is out to get us, we must be pretty important people. And a lot of people have trouble wrapping their minds around the fact that most people don't give 2 socks about us. Other instances as well, you're waiting for a bus. Buses come once an hour. If you show up at a random time at the bus stop, you'll wait in general about half an hour. But if the buses bunch up a little bit, still average once an hour, but they bunch up, you're much more likely to wait longer than half an hour than less than half an hour. Another area in which some simple mathematics sheds light on the difference between a kind of disembodied view from nowhere and a more parochial view is race relations. And following simple observation, I think, is suggestive. Assume that, contrary to fact, blacks and whites in this country occupy equal positions of power and influence. And assume also, unfortunately, contrary to fact, that the country is completely, totally, residentially, professionally integrated. And finally, assume that 10% of each group is racist, 10% of blacks, 10% of whites. Blacks constitute about 13% of the population. For the purposes of this thought experiment, I'll assume that everyone who's not black is white. It just makes it simpler. So 87% population is white, 13% black. In this case, the chance that a white person will run into a black racist in any given encounter is 1.3%. 10% of 13%, while the likelihood that a black will run into a racist in any given encounter is 8.7%, 10% of 87%. But if you run into more people, and of course everybody does, these differences get bigger. And not only do the chances of you running into a racist differ significantly between the races, but over a course of a lifetime, a black will encounter hundreds more racists than will a white. And the point is that minority status by itself brings about these disparities, since we're assuming equal rates of racism and complete integration. In fact, if these already idealized conditions held, but only 2% of whites and 10% of blacks were racist, blacks would still encounter more racism than would whites. And similar, of course, that has nothing to do with black and white. Similar remarks apply to other minorities, except for women who aren't really minority. So, I mean, as difficult as it may be to eliminate the scourge of racism, it'll be even more difficult to eliminate the perception of racism. Suggestive as this thought experiment may be, neither it nor other applications of mathematics is convincing, though, and isn't meant to be, but in the same way that a mathematical proof is. And one of the themes of the book is the difference between mathematical proofs and theorems, which are indubitable, and their applications, which are anything but. People often, wrap themselves in the mantle of mathematics and trying to borrow some prestige from the subject and hope that whatever it is that they believe will thereby appear more credible. But any bit of mathematics can be misapplied. I mean, the complicated stuff, even simple. I mean, 1 and 1 is 2. It's taken as a standard of indubitability. Of course, it's always true. But if you take a cup of water and add it to a cup of popcorn, you don't get 2 cups of soggy popcorn, you get about 1.5 cups. So 1 and 1 isn't always 2. Substituting equals for equals. This goes back to Euclid. It's always true in mathematics. Wherever you see a 3, you can put a square root of 9, or a cube root of 27, or the smallest, largest integer less than pi, and everything is still true. But in mathematics, you can substitute equals for equals, but not in everyday life. There's an apocryphal story about Reagan, to the effect that he believed that Copenhagen was in Norway. Copenhagen was in Norway. And, but Copenhagen equals the capital of Denmark. And you can't infer from Reagan's belief, if it were the case, that he believed that the capital of Denmark were in Norway. So in this case and many others, you can't substitute equals for equals. Trigonometry plays a big role in astrology and biorhythms, but that doesn't mean there's anything to those two pseudosciences. Or there's a story about the tribe of hunters that became extinct soon after they mastered vector analysis. And the reason is whenever they spotted a bear to the northwest, they'd shoot an arrow to the north and one to the west. Again, the mathematics is impeccable, but the application doesn't make much sense. Probability and statistics, of course, are misapplied every day. There's a demographic statistic I saw fairly recently that amused me, and that is that the average resident of Dade County, Florida, the Miami area, is born Hispanic and dies Jewish. Again, it doesn't bespeak any high rate of conversion, but it's true. Or sex surveys, even when they're done carefully and all the statistical protocols are observed and fine points are taken care of, they're still all based on a very dubious assumption, and that is that people tell the truth when asked about their sex lives by perfect strangers. I mean, the most recent Sex in America survey a couple years ago, University of Chicago Press, again, indicated that the average number of sex partners reported by males was much greater than the average number reported by females. And if those two critical numbers are so out of sync, it's hard to see how much credibility we could give to this study as a whole. Or more recently, the Viagra phenomenon. Up until this year, there were 17 American men who were impotent. And now there's more. More serious stories are examined in the book as well, or deconstructed: consumer price index, birth order, murder, death penalties. O.J. Simpson trial is rife with mathematics. Forget the blood work. Let me just mention two mathematical items that I think are interesting. One is Alan Dershowitz's claim in the first trial that evidence that O.J. Simpson battered his wife shouldn't be allowed because fewer than 1 in 1,500 men who batter their wives go on to kill them. And that's true, but it's stunningly irrelevant. The relevant statistic is what's the likelihood that someone who batters his wife or girlfriend and whose wife or girlfriend is later murdered, what's the probability that the batterer is the murderer? And there, given widely available crime statistics and something called Bayes' theorem, it can be shown that if the batterer is the murderer more than 80% of the time. So there's a prima facie case for looking at the husband. I mean, even without any other evidence, any individuating circumstances, 80% of the time, the batterer is the murderer if the wife or girlfriend ends up dead. The other piece that plays a role in the Simpson trial and lots of others is the notion of statistical independence. If two events are independent, in other words, if the occurrence of one doesn't affect the probability of the other, the probability that they both occur is obtained by multiplying their probabilities. So, for example, the probability of getting two heads when you flip a coin is 1/4, a half times a half, because they're independent. What does this have to do with the O.J. trial? There are lots of uncontested pieces of evidence there. The probability that O.J. Simpson would wear a size 12 shoe, maybe as did the murderer, maybe 1 in 20, I don't know. The probability that he would cut himself on the left side of his body the very night of the crime is indicated by the blood drops on the left side of the footprints. What would that be? Maybe 1 in 1,000. So those two uncontested pieces of evidence are independent. The probability that they both occur will be 1 in 20 times 1 in 1,000, which is 1 in 20,000. And there are other pieces as well, so, which make the probability even smaller. There's a countervailing argument called prosecutor's paradox, but it isn't strong in this case. In any case, the appropriateness of mathematical applications are continuously vulnerable to criticism. You have to always ask yourself when you apply mathematics, is this the right model to use? Are these assumptions warranted? Is there any other way to measure these quantities? And the soundness of applications is, in this sense, much more like the varying cogency of a literary interpretation than the validity of a mathematical proof. Speaking of literary criticism, I also draw a number of analogies between it and cryptography, and more generally between ideas in information and complexity theory and literary notions. How, for example, does one measure the complexity of a story? And what can we conclude from the fact that critical studies of a text are often much longer than the text itself? Let me cite here just one trivial example, though. It concerns the game of 20 questions, children's game of 20 questions. One kid picks a number between 1 and a million. The other kid, through a sequence of yes or no questions, has to determine what the number is. So you ask, is it more than 500,000? If so, is it more than 750,000, and so on. 20 questions are always enough because 2 to the 20th is a bit more than a million. But 20 questions are not sufficient if the kid is allowed to lie. If he lies once or twice, the number of questions needed to determine the correct number goes up significantly. If it's 3 or more, it goes up astronomically. And the lesson for authors, I mean, not so much from this, but from other things, is that unless their stories are intended to be terminally opaque or ambiguous or instances of magical realism of one sort or another, 1 or 2 lies from an unreliable narrator are more than sufficient to create an agreeable amount of doubt in the minds of the readers. In any case, whether in literature or in mathematics, codes of this sort and other sorts, like magic tricks and coincidences, appeal both to our rational and analytic side and to our sense of the spooky and the mystical. This is especially true of the so-called Bible codes. The more emotionally fraught a story is, the more eagerly people search for not only for agents, but for confirmation, and so on. In Once Upon a Number, I discuss Michael Drosnin's best-selling book, Bible Codes, and then his claim that embedded within the Bible are so-called equidistant letter sequences, which I'll explain in a second, which foretell future events. In any case, I explain what's wrong with this by examining a lesser-known recent discovery that's been suppressed by President Clinton's lawyers, and that is that encoded within the U.S. Constitution is a prophecy of the Lewinsky sex scandal. Placed there, presumably by the Founding Fathers, the 10 letters in the word Bill and Monica form one of these so-called equidistant letter sequences. In the case of the Bible codes, the text is the Torah, and the alphabet is Hebrew, but the same principle. Imagine that in the U.S. Constitution, at some point, there's a B for Bill. And then you move ahead, let's say 82 letters, and there's an I. Another 82 letters, an L, and then an M for Monica, O-N-I-C, each separated by 82 letters. People say, well, what's the likelihood, what's the probability of that sequence of letters appearing in those particular spots? And the answer, of course, is unbelievably tiny, just minuscule. And the inference that people who make these claims want others to make is that there's divine inspiration, and that's why the Torah has this. But it's like the Dershowitz case, it's not the relevant probability. The probability of those letters appearing there is tiny, but you don't have to start right here. You can start virtually anywhere in the Constitution. And you don't have to jump ahead 82 letters. You could jump ahead 46 or 118 or just virtually any skip distance between the letters. So you start anywhere, jump any distance you want. You don't have to only go forwards. You can go forwards, backwards, diagonally. And you don't have to look for just Monica. You could look for Paula or Kathleen or Jennifer or whatever. So with all this leeway and this generically characterized set of events, the likelihood of something of that general sort occurring is quite high. And people who have looked in other texts have found them essentially wherever they looked, in Shakespeare, in Moby Dick, whatever. There's one I like that's in the standard English translation of War and Peace. And there's a equidistant letter sequence for the word Chicago in close proximity to one for Bulls, in close proximity to one for Jordan. So Leo Tolstoy foresaw the dominance of Michael Jordan and the Chicago Bulls. And a more general problem, though, is data mining. People scour huge databases searching for any possible connection among the variables. And often they find connections which are real enough, but then concoct explanations for them that are baseless. I mean, comparable idea is the following. The companies commission dozens of studies, and even at the 5% statistical significance level, some of them are bound to show the connections that they want. And if they go public with those and throw away the rest, they'll impress people who don't know how these data were obtained. The point is we're inundated by torrents of data, and unless we ask where it comes from and keep our heads on our shoulder, our condition is described by a paraphrase of Coleridge that I like, and that is data everywhere, not a thought to think. It shouldn't be surprising, though, that mathematical ideas are invoked in narrative context. One of the suppositions of the book is that storytelling and informal discourse have given birth over time to these complementary modes of thinking used in mathematics. In the same way that geometry grew out of measurement, arithmetic out of counting, information theory out of informal ideas of meaning, these technical disciplines then develop a life of their own that's independent of us, but the origin is often quite mundane and murky. I mean, every major idea, not every, but most major ideas in statistics, probability, have precursors in everyday language, in colloquial English. Average, I mean, there's all kinds of words in English. Typical, standard, usual, regular, standard deviation. And the analogs in English, words like strange, bizarre, unusual, or far out. Far out you can think of as indicating far out in a distribution. Like Moliere's character, who was shocked to discover that he'd been speaking prose all his life. I mean, a lot of people are shocked to discover that what they characterize as common sense is often a kind of informal statistics or mathematics in general. It's telling, too, that the word account, simple word account, refers not only to numbers but to narratives as well. Related to this to these issues is a discussion of stories, statistics, and stereotypes. And although many assume that stereotypes are always evil vestiges of benighted mindsets, and as we see all too frequently, they unfortunately still are, nevertheless, quite often they're essential. They permit the economy of expression necessary for rapid communication. And like statistical studies, stereotypes sometimes pay their way by distinctly summarizing general information, whose many exceptions would be too time-consuming to know. In general, though, statistics tell us a few things about a lot of people. Stories, in contrast, tell us a lot of things about a few people. And this leads to the common observation that novels illuminate great truths of the human condition. They're multivalent, bursting with ironies, details, and metaphors, while social science and demographic statistics can seem simple-minded and repellingly earnest by contrast. But you can easily fool yourself into thinking that you're learning more of a general nature by reading a particular story or novel. To see why, imagine a very simple statistical study with two people and two characteristics, shyness and intelligence. Then, if the shyer person is more intelligent, you got a perfect correlation. More shy, more intelligent. If the shyer person is less intelligent, you've got a perfect correlation. More shy, less intelligent. Same thing if you've got three characteristics and three people. Or when the number of characteristics is a significant fraction of the number of people, the so-called multiple correlation among them will suggest all sorts of spurious associations. Yet these are the kinds of insights that come from stories in everyday life. In stories in everyday life, there are few people with all kinds of characteristics. So we tend to overestimate our general knowledge of other people when we read such stories or have such relations, and are convinced of all sorts of spurious associations, more complicated variants of more shy, less intelligent, that are simply bogus, and we fall prey to what's sometimes called the tyranny of the anecdote. Related to this is a common phrase. In stories, what do you do when you read a story? You suspend disbelief. And you're willing to make what statisticians call a type 2 error. In science and statistics, the mindset is just the opposite. You suspend belief. You don't want to be fooled. And you're willing to make what statisticians call a type 1 error. They're known for being very evocative and lyrical, they're statisticians. Anyway, suspending belief, the latter careful and skeptical mindset is much less natural, I think, and lies behind some of the common stereotypes of mathematicians, which even mathematicians engage in often. My favorite joke about a mathematician is, stereotype of a mathematician is the definition of an extroverted mathematician, and he's the one that looks at your feet while he's talking. Anyway. Interestingly, the figure of the mathematician is increasingly common in popular culture. The movies Pi, Good Will Hunting, biographies of Paul Erdős and John Nash, Fermat's Last Theorem, even the Unabomber in some weird sense. In regard to this last, I was accused once in several letters to the New York Times of stereotyping mathematicians. The story involves the Unabomber's manifesto and is marginally relevant, so let me briefly digress. When I first read the manifesto, I thought that it was written by, I had a hunch it was written by a mathematician. And I mentioned it to my wife, and that was it. But later, when the Unabomber was arrested and his mathematical background was revealed, I wrote an op-ed for the New York Times, and in which I opined that his credential, his PhD in mathematics, wasn't that anomalous a credential. And there's a large element of whimsy in my op-ed, but I pointed out that the manifesto was axiomatic in nature, a few basic axioms, self-reliance, minimal environmental impact, and so on, and everything else follows from that. It was meticulous. Mathematicians are generally meticulous. It was very abstract. Abstraction is certainly a characteristic of mathematical thinking, but it's also been associated with various dissociative pathologies. And it's clear how someone trained in such reasoning and enthralled to some ideal could come to justify murderous and evil acts as some nebulous good. And mathematics is beautiful, but its aesthetic, like the manifestos, it seemed to me, was minimalist and austere. Anyway, I added that most mathematicians are psychologically quite ordinary, and of course they are, and they're frequently humorous, seldom asocial. They only use the phrase blow up when they talk about dividing by zero and so on. In any case, in Once Upon a Number, I also discussed con men, killers, mathematics and humor, lotteries, and so on. But I returned frequently to notions of logic and information used in mathematics and comparable notions in different and comparable logics in narrative. On the whole, though, narrative logic is much more complicated, maybe contrary to popular impressions, than is mathematical logic. It deals with individuals, with points of view, with motives and reasons, which are much more complicated and various than physical causes and movements. I mean, even a little action, you touch your hand to your head, can mean indefinitely many things depending on the context. It could mean you've got a headache, you're signaling a third base runner, your toupee is falling, there's something in your eye, and so on. You don't have anything like that in mathematics. You don't have substitutability in narrative logic, as I said before. 9 square root of 81 mean the same thing. That's not true in narrative logic. And sometimes terms change meanings within a matter of seconds. I mean, it's a joke about a kid calls home, talks to his brother, and asks about his cat. And the brother says, the cat died. And the other brother says, well, couldn't you break it to me? I loved that cat ever since I was a little kid. And, this is awful. Couldn't you say it was on the roof? And then I call next time, and, I couldn't get it off the roof. And I call the third time, then you can tell me. And the other brother apologizes. All right, I should have done it that way. And then the kid says, well, how's mom? And she's up in the roof. Anyways, I mean, that means something different than it did 30 seconds ago. You don't have to worry about that in mathematics. Moreover, because of its sensitivity to social context and because it presupposes a personal sovereignty in others, story logic is what I call implicative. It implicates us, it entangles us in the lives of others. Whereas mathematical logic, and math and science in general, is what I call extricative. It takes us out, it disengages us. We can look at policies or biological phenomena or galaxies from the outside. And I think that's part of the appeal of mathematics, and it certainly was for me. I remember I was about 10 or 11, and I remember thinking, I remember I was in study hall, and they said, atoms can't think, and people are made out of atoms. Come to believe characterizes many 10, 11-year-olds. I thought that no one had ever had this piercing insight before. So I wrote it up very carefully in a piece of paper. Atoms can't think, we're not made out of atoms, we can't think. Folded it up 6 times, covered it completely with tape, put it in a metal talcum container, and sealed it in plastic glue, and buried it in this swing set behind our house, and for future unthinking generations to discover. But nevertheless, one reason for writing about the relationship of stories to statistics, though, and of these different mindsets, is that it mirrors the more general relationship between C.P. Snow's aforementioned two cultures, but it doesn't arouse all the standard knee-jerk platitudes. Unfortunately, though, the chasm between these two cultures still exists, each side continuing to hold the other in a mild contempt. Many literary intellectuals publicly speak and write as if they're the only kind of intellectuals there are, while many scientific intellectuals secretly believe that much of the scholarship in literature and the humanities is pretentious and muddle-headed blather. John McCarthy, just down the street, is a scientific intellectual, the latter type. He's at Stanford, one of the earliest researchers in artificial intelligence, invented Lisp and so on. And he's attempted to elucidate differing mindsets via the following little story called The Doctor's Dilemma. He asks us to suspend disbelief. It's a story. A miracle has occurred, and a young doctor can cure anybody with the merest touch of his skin. And he wants to know how best to use this amazing ability. And before giving his answer, McCarthy lists what he claims are standard literary responses to this dilemma. These include the following scenarios. The doctor arouses the jealousy of his colleagues, and because of that, they put him in jail. He doesn't cure anybody. Or a church charges him with sacrilege for tampering with man's inevitable lot, and he doesn't cure many people. Or on the other hand, he's deemed so holy that he's kind of hemmed in by ritual, and he doesn't cure many people. Or he becomes exhausted from his ministrations and he dies. Or on the other hand, he succumbs to an increasing desire for power, money, and women. Note that for him, unprotected sex is safe sex, but that's something else. And he goes on and on like this for pages. And then he finally provides what he describes as a moral solution. And it involves some arithmetic, that 100 million people under 70 die each year and so on. And his solution involves a complicated pulley system. And he erects one in each continent, and 10 or 20 pulleys drag 10 or 20 people past his fingers every minute. And he need work only about a half an hour a day and can cure everybody. So again, this extricative tendency of mathematics or mathematical thinking, I think, is apparent even in parody. So finally, though, let me mention one last difference between narrative logic and mathematical logic, and that's the notion of common knowledge. Not just knowing something, but knowing that others know it and knowing that you know it and so on. And it's something we don't have to worry about in mathematics or science, where you don't have to deal with other knowers. I'll illustrate with two stories about the stock market. And mention the stock market because with regards, we have two different approaches. Both make sense and are both very tempting. Mathematical, where you talk about random walks and beta values and so on, and a narrative, where you talk about greed and exuberance and fear and so on. In any case, the first story involves probability course I gave a number of years ago during the summer, and it met every day during the summer. In order to induce my students to keep up, I gave a quiz every day. And at the bottom of each exam sheet, I had a little box. And next to the box was a little notation stating that any student checking the box would receive 10 extra points on their exam, provided that fewer than half the students in the class checked the box. If more than half the class checked the box, then those checking it would lose 10 points. It was a kind of cruel pedagogical practice. But anyway. So, excuse me, what happened is initially a couple people checked the box and they said, oh, it gave me 10 points. And gradually more and more people checked the box until the number checking it went over the 50% mark, at which time the number checking it dropped precipitously, and then it edged its way back up, and it hovered around 40%, but it was always a different 40%. And it struck me that the calculations that my students had to go through to decide whether or not to check the box were very complicated, because they had to anticipate other students' anticipations of theirs in this kind of complicated self-referential tangle. It was very skittish. And the reason I say the stock market is that I've learned since that Santa Fe Institute, whose researchers study chaos, have used a model very similar to this to to study the behavior of investors, where again, investors have to anticipate the decisions of others investors and their anticipations of them in a similar kind of self-referential tangle, which is very subject to change, which is why one reason the stock market's so hard to predict. And last story is the parable of the furious feminist in the stock market, and I think I'll read this. This parable, which illustrates the importance of the notion of common knowledge, again takes place in a benightedly sexist village of uncertain location. The statutes of the village require that if a woman can prove that her husband has been unfaithful, she has to kill him that very day. Moreover, the women are highly intelligent, aware of each other's intelligence, and always abide by the statutes. But though they are also terrible gossips, they are careful to spare each other's feelings. As a result, each of them knows immediately when another woman's husband has been philandering, but never when her own has been doing so. As it happens, all 50 of the men have been unfaithful. But since no woman can prove her husband has been so, the village proceeds merrily and warily along. Then one morning, the tribal matriarch from the far side of the forest comes to visit. Her honesty is acknowledged by all and her word taken as law. She warns darkly that there is at least one philandering husband in the village. Once this fact, only a minor consequence of what they already know, becomes common knowledge, what happens? The answer is that the matriarch's warning will be followed by 49 peaceful days, and then on the 50th day by a massive slaughter in which all the women kill their husbands. To see why this is so, imagine there's only one unfaithful husband, Mr. A. Everyone except Mrs. A already knows about him. So when the matriarch makes her announcement, only she learns something new from it. Being intelligent, she realizes she'd know if any other husband were unfaithful. She thus infers that Mr. A is the philanderer, and she kills him that day. Now, assume a different case. There are only two unfaithful men, Mr. A and Mr. B. Every woman except Mrs. A and Mrs. B knows about both these two cases of infidelity. Mrs. A, though, knows only of Mr. B's, and Mrs. B knows only of Mr. A's. Mrs. A thus learns nothing from the matriarch's announcement, but when Mrs. B fails to kill Mr. B the first day, she infers that Mr. A must also be guilty. The same holds for Mrs. B, who infers from the fact that Mrs. A has not killed her husband on the first day that Mr. B is also guilty. The next day, the second day, Mrs. A and Mrs. B both kill their husbands. Now, if there are three guilty husbands, A, B, and C, the matriarch's announcement would again make no impact the first day, but by a reasoning process similar to the one above, each of Mrs. A, B, and C would infer from the inaction of the other two on the first 2 days that their husbands were also guilty and kill them on the third day. By a process of mathematical induction, we can conclude that if all 50 husbands were unfaithful, their intelligent wives would finally be able to prove it on the 50th day, the day of the righteous bloodbath. Now, if you replace the warning, of the matriarch from the far side of the forest with that provided by the Thai, Malaysian, and other currency problems last summer, the nervousness and uneasiness of the wives with the nervousness and uneasiness of investors, killing husbands with selling stocks, and the 50-day gap between the warnings and the killings, with the long delay between the East Asian problems and the recent sell-offs this past summer, you have the analogy, strained though it may be. The Malaysian Prime Minister's speech criticizing Western banks in April '97 may have functioned as the matriarch's warning and precipitated the crisis he most feared. Happily, unlike the poor husbands, markets can be resurrected, and this one seems to have done so. Such is life, death, buying and selling in the global village. The story may seem rarefied and abstruse, but we make even more intricate and subtle inferences every day, and you're probably doing so right now. I caught you. In any case, after all these stories, parables, and so on, which side you come down on, stories or statistics? And the answer, of course, is both. So let me end with a joke which is illustrative, but unfortunately not very funny. It involves two hard-headed scientists, and the first one says, this talk of motives, promises, questions, it's sloppy. I hate it. Why don't we just simply cite facts, get the numbers, use mathematical logic, forget all this messy stuff? And the second hard-headed scientist says, I know exactly what you mean. Let's just vow right now to do that. And we, like so many others, yearn for clarity and precision. any case, the joke, such as it is that these hard-headed scientists are planning to use only mathematical logic, but narrative notions are built into that very joke, that very interchange, that very communication. I want to do this, I don't want to do that, this is sloppy, and why don't we simply, and so on. The point is, scientific and mathematical understandings grow out of and presuppose these more nebulous notions of narrative, and they're really impossible to get rid of. I mean, trying to do away with them is rather like shouting about the importance of silence, or claiming that one's brother is an only child. The murky area between stories and statistics must ultimately be filled by us. We're all storytellers, we're all number crunchers, and we're all better off if the tariff between these two realms is eliminated. Thanks. Thanks. Thank you very much. I'd be happy to entertain comments, questions, jokes. Yeah.
You had mentioned that the guys who do data mining have drawn dubious conclusions.
Right.
Any example?
If they stick to just the question was, because you can't always hear the question, the people who do data mining sometimes draw dubious conclusions from this practice. And if they stick to the empirical connections and associations, there's no harm done. Sometimes there are connections and people don't know what causes them. I mean, they find that people whose gums bleed when they brush their teeth are more prone to heart attacks. And there are all these like strange connections. And where they go wrong is when they try to explain them. And sometimes the explanation is just accidental. And many times people just don't know why the connection is there. So it's not so much that there aren't connections between these disparate variables. They may very well be. I mean, sometimes people, by using data mining techniques or cluster analysis, find strange connections and do come up with something that explains them. But more often than not, they're just empirical associations, and if you can sometimes make use of them. But it's when you go beyond that and say, this is what caused it. I mean, so the analogy with Bible codes is strained, but it is somewhat similar. I mean, there are these codes that, but it's the explanation that's involved. Yes?
Your story about the cheating husbands and the wives,
right.
Sounds like one I heard about pirates, 5 pirates who are trying to divvy up their bounty. I don't know.
I'm sorry.
5 pirates.
Right.
I don't want to go into it.
Okay.
A little bit. Who are trying to
come up here and
to divide their bounty, and it sounds like something that would be in your book. I guess it's not. Or
no, that's not. But I mean, what I found interesting about that is just this notion of common knowledge. I mean, there are all kinds of facts that everybody's aware of that don't motivate us to do anything. But once they become common knowledge, we all know them. We all know others know them. They know we know them. They take on a totally different cast, and it's not a very well understood notion. There are people, again, at Stanford and other, John Barwise and so on, that have studied what's called situation semantics, trying to formalize these informal understandings that we all have. But it's nowhere near accomplished, and we all know much more than we know how to formalize. But common knowledge is one thing that's quite difficult to get clear on. Hi.
Were you aware that 83% of all statistics are made up?
On the spot, yeah. No, it's actually 83.628% of all. Okay. The question was I aware that 83% of statistics are made up? And I corrected the questioner. Any other questions coming? Hi.
I'm curious as to if you, although I'm sick of lists all the time, but still the idea that there are some ways that that we as human beings are systematically biased against understanding some things in a mathematically correct way. I don't know, because you cite some of those. I mean, for example, I think we're all biased towards noticing loss versus gain. I mean,
right,
we're more worried about somebody being mean to us than noticing when someone's nice to us.
Right.
A psychological bias, or viewing coincidences where they aren't really there because we're just not thinking in terms of the universe of all variables. Did you come up with any sort of set of...
Well, there's a lot of work that's been done. I mean, some in Once Upon a Number, this book, and some in the Numeracy, and Tversky and Kahneman have done a lot of stuff, as have others, on a psychological, this kind of murky area between our psychologies and mathematics. And regression to the mean is one. I mean, You go to a restaurant, it just opens and it's great. And then you go back the next time and it's not so good, and you say, this stinks, I'm not going to go back again. And it's probably just a regression to the mean. It also works in the other direction, but if you go to the restaurant the first time and you get deathly ill, stomach ache, you're not going to go back, because next time it'll probably be a little bit better. But yeah, I mean, there's always a tendency to read significance into coincidences, for example, and I mean, we're pattern recognizing animals, and this kind of hardwired, quasi-innate capability, I mean, leads us astray sometime. I mean, it was useful to correlate any sort of, rustle in the leaves with some other kind of natural phenomena. Anything was grist for a mill, but now we're inundated by so many numbers and letters and acronyms that this innate tendency to look for patterns often fools us. And yeah, it is an interesting area. And then there's a natural tendency to, I mean, stories are always more compelling than our numbers. I mean, there's an interesting juxtaposition. I like Jesse Ventura, the former wrestler, was elected governor of Minnesota, got a lot of national publicity. The Democratic candidate for governor in Pennsylvania, my state, is a PhD in mathematics, and he barely beat the third-party candidate. And I mean, it's I can't, obviously doesn't prove anything, but storytelling always trumps number crunching. But in any case, other questions, comments? Hi.
Have you looked into web auctions?
The question was, have I looked into web auctions? No, but auction theory is a very interesting area. And in fact, John Nash, whose recent biography, A Beautiful Mind, contributed some interesting results. I mean, that are results that can be applied to auction theory. But on the web, I'm not quite sure, even though it sounds like it adds something new, I'm not quite sure it does. But
Well, admittedly, my sampling is not very good, but it seems like I've noticed that even if the price of an item starts out at $1, that given enough items out there for sale, the price approaches what people would go to Fry's and spend, or go to the
Right.
store and spend. And I wonder, is that what's going on in that? Is there statistics? Is it a market force? Is it people are biased by the prices they've seen, so that's their expectation?
I'm sure a lot of things. It's an interesting. I mean, the question is, the auctions on the web, and even if the price starts at $1, it tends to rise to its market level. And what is it that people know what the quote real price is, or competition, or whatever? There's a variety of psychological, economic factors. I mean, I think an interesting kind of general observation that's marginally relevant is that this field of economic behaviorism is getting more and more common, and again derives from the work of Tversky and Kahneman and so on. And again, this kind of murky area between numbers and our psychologies. And we have a lot of good insight into some of what we do. I mean, we're more averse to risk than gain in certain contexts and so on, but it's still poorly understood. Yep.
Something I've been kind of puzzled with. This may be a simple question, but I haven't heard the answer. If I'm trying to express something as a probability, like it's probably going to rain tomorrow, like 60%,
Right.
but I also want to be able to convey how certain I am of that estimate.
Right.
Did I just read the weather report, or am I just kind of making it up? Is there an easy way to express, I'd like to see the weathermen say,
mean,
not only they're what they think it's going to do, but how confident they are.
You mean like give confidence? The question is, if somebody says, the weatherman says there's a 60% chance of rain, that doesn't say anything about how confident the weatherman is of that figure. And are there any weathermen anywhere that give confidence intervals?
I didn't know if there's a language for doing that.
Well, I mean, you can use confidence intervals. I mean, 95% of the time when the conditions are thus, it rains between 40 and 82% of the time. But I think that would probably cause more confusion than not. But yeah, weather is. They're just marginally relevant. But I was on a hotel last night and I was looking at reruns of the Nagano Olympics, and they were talking about the site is not a good site because of the volatility in temperature. In 1 hour, the temperature varies 25 degrees centigrade, and then they said this corresponds to X degrees Fahrenheit, and all they did is translate 25 into Fahrenheit, and instead of looking at delta, so-called delta Z and delta F. But anyway, I mean, but that's the kind of thing that most people don't notice. But anyway, yeah.
Well, in the case of weather, I'm not sure about other fields, but in the case, I think the confidence interval is built into the percent, basically. So,
Yeah. No, but I mean, but what if? How so?
The percentage is based on, given the statistical variance of the weather for the next day, then 30% of the time it will rain. Therefore, we predict a 30% chance of rain. That's where that percentage comes from.
Yeah. Okay. Maybe
That's
you
exactly
can.
what you're saying.
Yeah.
Well,
Okay.
the two people could say it's probably going to rain tomorrow with a 3/4 probability.
Right.
One might be very certain. One might just be, well, I kind of made it up. But
Right. Well, that's what I'm getting at. Is that when a weatherman says it's going to rain, there's a 30% chance of rain or 60% chance of rain, they're referring to a statistical database that basically says when the weather is like it is, will be tomorrow, then 30% of the time it'll rain.
Actually, I mean, and maybe it's a nice close, but it's a good illustration. I mean, this little discussion of the difference between the mathematics of probability, which is quite well understood, and the applications, which are open to all kinds of discussion, and not just probability, but mathematical applications in general. Anyway, thanks again, and I'll be happy to talk more. Thank you. So, I think I went a little long.
Then go to HTML.